This is lesson 9.4. I want to first have you do question of the day just to practice some of the things that we've been doing. This first one is going to practice either the FOIL or special products. Number 2 is also a special products problem. And then number 3, this is a function notation with just doing another special product problem, but it looks different, so I want you to feel comfortable with that as well. This is just saying take whatever function f of x is and times it by g of x. So this is the function of f of x times it by g of x. Alright, bring that to class tomorrow and remind me to go over it. I keep forgetting to go over those, so remind me to go over it. Thanks. Lesson 9.4 is going to be talking about solving polynomial equations in factored form. It's going to actually help us find what the actual variables can be. So the first thing that we're going to talk about is the zero product property, which basically says, and it looks kind of funny when they do the algebra, any variable, but I'm going to give you an example and it should make sense. It says let a and b be real numbers. If a times b equals 0, then either a is 0 or b is 0. That's pretty easy if you kind of think about it. If the answer to our multiplication problem is 0, then we know one of the terms is 0. So we're going to use this to help us solve problems. The zero product property says that if this times this equals 0, then either this right here is 0 or this right here is 0. So what I'm going to do is I'm going to set those both equal to 0 and put my answer as it's either this or it's this. Okay, so the work that I would show would be x minus 4 has to equal 0 or x plus 0 has to, or sorry, x plus 2 has to equal 0. Bada bing or bada bing. So we're gonna solve for x on this one and we'll get x has to be 4 or subtract 2, just solving those equations, and you get x equals negative 2. This is my solution. We're not sure which one is the case, but it's got to be one or the other. Okay, that's what the zero product property means. Before, we didn't have it equaling 0, so we just put, did the FOIL, and we kind of simplified it the best we could, but that was because it wasn't equal to anything. We couldn't solve it. But now, because it's equal something, we can actually solve it. Alright, now this is something that we cannot solve because it doesn't equal anything, but we can factor out the GCF. Okay? Greatest common factor. So when I look at 12 and 12x and 42y, I want to pull something out front. Okay, it's kind of like the reverse of what we've been doing. We're going to have a term in front of our binomial, and then we're going to get a binomial back. Because 12x and 42y have something in common. And last year, I'm not sure if you remember this, but you did factor trees to kind of break down and find the GCF. I'm just going to see if you remember. This is what I've been doing with my other class. So you break these down. Step 1 is to do the factor tree. And then 21 is 3 times 7. So this is the prime factorization. So for 12x, after step 1 is to do the prime factorization. Step 2 is to write the prime factorization in expanded form. So you get 2 times 2 times 3 times x. There's an x there. And then we have 42y. And you'll get 2 times 3 times 7 times y. And for GCF, you circle all the friends. Oh, look, the 2 and the 2, yay, they're friends. And then we have the 3 and the 3, all the pairs. And so then you multiply those out, and you'll get the GCF of 6. You might know that too. You might say, well, I just know that 6 goes into both of those and that's the biggest number that can go in. But this is how you find it. So we're going to take the GCF and put it out front. Loop, GCF. Then we need to kind of do the reverse of what we've been doing, the whoop-de-whoop. So 6 times what makes this first term? 6 times 2x. Do you see that? That would recreate that. So we're doing like the backwards. We're going in reverse. Plus 6 times what makes this? 7y. And that's going to be this simplified. We factored out a common factor out of both of them, pulled it out front, and then recreated our new binomial inside. Okay, so on this one in green, but if I have 4x to the 4th, it's going to break down into 2 and 2. Let's see if I can scroll down for us. And then 24x to the 3rd is going to break down into 4 and 6, 2 and 2, and 2 and 3. And then I organize my information, and I have 4x to the 4th, so I write it in expanded form, 2 times 2 times x times x times x times x, and 24x to the 3rd is going to be 2 times 2 times 2 times 3 times x times x times x. And I circle my friends, the 2's, and then I have 3 x's that are in common. And then I multiply those together. So I have 2 times 2 times x times x times x. So that's going to be 4x to the 3rd. That's our GCF that comes out front. That's what I can pull out. Pull that out of each term. Do you agree? There's a 4x to the 3rd in there, and there's a 4x to the 3rd in there. That's what I'm pulling out of each of those terms. Now I have to get back to each of those. So what do I need to multiply this GCF by to get that? X, right? And what do I need to multiply it by to get that? 6. And there you have it. That's you're factored out a GCF, and that is rewriting that. It's equivalent, but it's written in a simplified form. Okay? Now we're going to take both of those things. We're going to take the GCF out, and now see how it's equal to 0? We can actually solve it. Then solve. GCF, rewrite, then solve. So I see 2x. I don't even have to do the GCF. I just can pull out a 2 out of each of these, and then usually what I go by is the lowest number of the variable is what I can pull out. There's no more than 1x that I can pull out of that. So it's the smallest number. So then to get back that first term, I'm going to times it by x. To get back that second term, I'm going to times it by 4. This equals 0. Now the zero product property says that if this is the case, if this equals 0, either this term, because that's a term, or this term has to equal 0. So I'm going to say 2x has to equal 0, or x plus 4 has to equal 0. Solve it, and you get x equals 0, or I'm just going to put it without parentheses because I don't need the parentheses. X equals -4. So I've narrowed down, because I know that this equals 0, and I rewrote it, I can figure out what x can be. Either 0 or -4. Alright, here is another one. They're going to give you some of these that have terms on both sides of the equal sign. We can simply just subtract 15n from both sides to get them so they're on the same side like our last problem. And when nothing is left over here, we can say it's equal to 0. So now this looks like what we just did. Okay? A lot of times I tell you, you want things on both sides of the equal sign, but here we can get rid of that, put it on the other side, and say, well, we got rid of everything over here, that's 0. Now pull out the GCF, 6 and 15. 3 is the biggest constant that can go into both, and then I have an n that can be pulled out of each. We're going to have to multiply 3n back to get 6n squared, and we'll multiply it by 2n minus 5. And that equals 0. Then we're going to set this equal to 0 or this equal to 0. N equals 0, or, and just spend a little time solving that. Show your work, make your work neat, please. Most of you are doing a really good job at that, so I appreciate it. And then I'll get n is 2.5, or you can write 5 over 2. I don't care how you write it, but I would prefer not a decimal, like either improper or mixed number. Okay? I will see you later, and have a good night. Bye.